Hello, everyone. This is Belinda Carr. Welcome back to the Movers and Breakers podcast, where we dive into the world of construction and explore the stories of people and companies who are shaping the future of our industry. From the latest innovations to the challenges and triumphs of everyday professionals, we bring you the inside scoop of what's happening in construction. Today, I'm speaking with Scott Mitchell, founder and CEO of Stud.io. Thanks for joining us, Scott.
Yeah, thanks for having me.
So you and your partner, Adam, are based in Boston, based at Autodesk's facility in Boston. That's something we'll dive into later. But you're currently at a project in California. At least you were the last time you spoke.
Yeah, I actually temporarily relocated out here to California because a lot of our projects are in this area, either in California and in Nevada and Colorado are really where most of our projects are at the moment.
And the work that you do, we'll dive into the details of your company, but does it require you to move around from project to project quite a bit, more than you expected?
It doesn't require it. It's a requirement, I guess, I've made of myself. And we'll probably get into this a bit more, but we do design work, construction design work, and we also develop software.
Yeah.
And we found that it's really important to be integrated in the teams that are actually building stuff with our software. And so we just like to be really connected with that. And so, no, I'm not required to be here, but being here it makes the collaboration a lot better.
So like me, you have a bachelor's in architecture. A master's in architecture, but you also have a master's in computer science. And you started off being an intern at a couple of architecture firms, but you managed to get out of the architecture world and enter the world of computational design, which I find completely fascinating because I was kind of a BIM director for an architecture firm once, and I'm passionate about the role that computational design is going to play in the construction industry. So that's a pretty bold jump. How can you tell us a bit about your story, how you carved this path?
Yeah. I think I'm really fortunate to have ended up where I am, because it's definitely throughout architecture school, the computational side of things, and particularly the computational fabrication side of things was definitely my interest. But I started grad school as just an architecture student, and I fully expected to graduate from architecture school to go work for an architecture firm and become an architect.
Yeah.
And a couple things happened. First, I quickly realized that for whatever reason, I just loved kind of algorithms generating my designs. I don't know if that was laziness, right? Like, you don't want to redraw things every time something changes. You want to come up with an algorithm that's going to redraw it for you. Or just kind of the fascination with math and logic and geometry. Probably a combination of those two things. So I quickly kind of discovered that passion, and didn't really know Grasshopper, but I was using like Excel to create designs and stuff like that. And I discovered Grasshopper and couldn't really stop using Grasshopper, to the detriment of my architecture projects, because when you don't really know computational tools, it's hard to produce great designs with them. But I struggled
But
through
the
that.
fact that you were exploring, that's what matters. Sometimes the outcome doesn't. It's the process that does.
That's a really good point. So I did familiarize myself with failure and learning from that failure.
And this was during school or at a firm?
This was during school.
Okay.
So this was the first year of school, just discovered that passion. And then the second thing that kind of led me to this alternative path was that I did work at a couple architecture firms. And I wouldn't say I struggled with it, but I didn't find really a passion at those places. I learned so much, and I'm grateful for those opportunities. But I sort of left those internships at corporate architecture firms with the feeling of it wasn't really satisfying to me.
I completely understand what you're talking about, because I was at UC, University of Cincinnati, and they had a co-op program. So we had 1 semester in college, 1 semester out on co-op. And every time, it was a wonderful opportunity, very, very grateful for it, just like you. But every time I left the co-op, it left me with a bad taste in my mouth. Like, this isn't what I expected at an architecture firm. I do not want to be just drawing elevations and doing mundane, repetitive work. That's kind of why I got into BIM, because I was trying to find a way to be more productive. It seemed like everything was so, the way architecture firms work was so unproductive. So it seems like you had a similar experience in that sense.
Well, definitely. I think there's also something super rewarding. Like I was good at computation, right? And I wasn't bad at architecture, but like I just it was hard to make myself really valuable and it's super competitive in just like architecture. But I found myself being more valuable when I started doing computational stuff,
Yeah.
which was a rewarding thing, and it's kind of a feedback there of positive reinforcement when things are going well. You want to learn more computation.
And you kind of set yourself apart in that way because you're not just an intern architect. You have a separate set of skills that can be more appealing to other architecture firms. It opens up a different world, a different career path, I think.
Yeah, and I would say multiple career paths.
Yeah.
I mean, I've talked to architects recently, and I find it surprising that there are large architecture firms that don't have computational designers. And to me, that seems crazy because it's just such a valuable thing to add into a design project. So I think that's just going to become more important moving forward. And I also have noticed more and more contractors have computational designers
Really?
as
Wow.
well. And it's definitely a valuable skill set that is just going to continue to grow in AEC.
Yeah, absolutely. So at some point in your career, you started working at Autodesk, and it seems like that was a pivotal moment that opened up a lot of doors for you and eventually motivated you to take the jump, take the leap into starting your own firm.
Yeah. Yeah. Autodesk, we still have a great relationship
Yeah.
with Autodesk. And you're right. That was one of the most fortunate opportunities I've had. So I started at Autodesk as an intern. This was the last summer, the summer before my final year of grad school.
Okay.
And the way, I don't know if their internships work this way still, but the way that the internships worked at the time was they kind of just gave you a project prompt at the beginning of the summer. You just executed that prompt, dove into that prompt for the summer, and then you came back and gave a presentation at the end, which is
With no supervision, it's all on you.
I mean, you would check in,
Wow.
but our manager, he was great, and he basically let us go do what we thought was the right thing to do. Of course, people were guiding us, but yeah, to some extent, completely unsupervised. And but like in contrast with my architecture internships, like that's very different.
Absolutely. Yeah. My architecture internships were, here are 5 drawings with red lines. Complete these 5 red lines, come back to me, and then I'll entrust you with the next 5 sheets. There was a high level of micromanagement. So what you're talking about is the polar opposite of that.
Yeah, complete opposite.
Yeah.
And on top of that, my prompt. So other people got prompts that were pretty interesting. I can't even imagine getting a better project prompt. They just showed me the Howick machine, which is the steel stud roll forming machine that we create software for. My company does now. And they said, see if you can do anything cool with this machine. That was it.
Wow.
And they said, we have a feeling like there's, some capabilities that aren't really unlocked right now, and you could do something cool with it. Just go see what you can do. And, Autodesk they had the technology center there, which they have the material, they have the machine. It was basically just up to me to play around with that machine and see what was possible with it. And as it turns out, there's a whole lot that's possible with it that people weren't really taking advantage of beforehand.
And you unlocked all that during your internship over there. You found something that, an innovative project or innovative software that you built?
Yeah, I mean, at least started to.
Okay.
I definitely would say I unlocked all of that at that time. And we might talk a little bit more about this later, but even today, so you have machines, and in the Howick machine, the roll forming machine is just like a prime example of it, that are built with these really particular use cases for digital fabrication workflows. And I think even the people making the machines, they don't necessarily realize that there's this latent potential for other use cases, given the capabilities of the machine. And
What are
so that,
some of those potential opportunities?
so with steel studs in particular, um, these machines have just a quick kind of high level understanding of how the machines work. They take in a roll of steel. There's a punch box that punches out different holes, and highly constrained holes. Like let's say it's a 1-inch diameter hole in the center of the stud, but anywhere along the stud.
Yeah.
It would be like one type of hole. And so it's meant to, there's a couple of different connections that those holes are kind of designed to make. So it punches those holes out. It rolls the steel up into the shape of a stud, and it cuts it to length. That's the machine. It turns out like there's ways you can punch those holes into the stud so that you can do stuff with those like different studs coming together after you get them out of the machine. And the best example of it is curving the studs. So we found ways to punch the holes in certain locations, and the software does this so that once you get the part out, you can segment it in a really precise way to make whatever curve you want to make. Which is the best example, but there's a bunch.
And that's with no alterations to the machine itself.
Correct.
Those tools that it already has those tools. This was just an extra functionality that can be added to that machine that no one was doing before.
Exactly.
Wow, that's cool.
Which I think like we found other things like that. And that's incredibly valuable, right? So if someone has some machine, they're doing whatever it is they want to do with it. In the case of steel stud machines, they're building walls and panels with it. But to come to them like, actually, you don't have to pay anything extra. Just use our software with your current machine as it is right now, and you can self-perform a whole bunch of new stuff that you may have not thought that you could do before. That's a big deal, and I think that's the reason that we've been successful, is that it's low cost in that regard to start doing some of these things.
So you started Stud.io 4 years ago. And I usually ask people about the origins of their company name, but I don't need to ask you that because Stud.io is obviously very straightforward. It's very smart. I have to say that. It's very smart, but it's very straightforward. So when you started the company, it seems like it was just a progression of what you had discovered at Autodesk, and you said, I can do a lot more by myself. Is that what you were thinking when you started the company?
Not quite. So it's definitely a continuation of that. We should add in here that there was a year plus in which I was working at Autodesk on in the generative design group. So I was just a software developer.
Okay.
After school, I was a software developer at Autodesk. And then the Howick stuff, the steel stud stuff, was happening basically in my spare time. And every opportunity I could to make it cross over with my day job, I did. So the reason I left after about a year of full-time software development at Autodesk was because I had a project opportunity to go use the software. And the client wanted to use the software, and they wanted my help doing it. And I first approached Autodesk and was like, hey, can we just like somehow incorporate this into my job? And they were super supportive, but they're like, you're a full-time software developer. You're not a construction consultant. And they were actually, so anyways, it wasn't an opportunity I was going to miss.
Yeah.
And they knew that. And so I actually transitioned to working part-time as a consultant for Autodesk while also going and taking on this other role and starting Stud.io. So Autodesk was super supportive of it, which is, again, I was just really fortunate to be in that position.
I always say this, like whenever someone talks about how did you get to a particular stage in life, or when they look at someone successful, I feel like it's a combination of luck and hard work and just being in the right place at the right time. It's and it's always in hindsight. Like you in 2023, looking at your career so far, you can identify all these moments where like the right client came to you at the right moment and you were at the right company that encouraged you to go pursue that client, and you had all the right tools and you were on the right path. And it's just, it's beautiful to think of it in hindsight and see how it all came together and led to where you are now.
That's a really interesting way to put it, and I kind of thought about that before, and I don't know if I have an answer to like why did that all work out, because
Yeah.
it did all weave together in a really fortunate way.
But it
And
was you working hard. That's also
that's
very, very
definitely part
important.
of it. It's
Yeah.
still working very hard, but that can't be.
The
That's not
only
it.
reason. Yeah. It's true.
um, but it did. I wonder sometimes, like, if I hadn't had that internship project where they said just see if you could do something cool.
Yeah.
If that hadn't happened, we wouldn't be here talking about steel studs right now. But would we be here talking about something else? Would some other opportunity have popped up? And
Yeah.
I don't know.
Yeah.
I might have just been lucky.
Yeah. There's this movie from the early 2000s, it's a pretty bad movie, The Butterfly Effect,
Oh yeah,
with Ashton
it is a
Kutcher.
bad movie.
But that was a very bad movie. But that, but there's the
It's a
idea.
good bad movie though.
It's a good bad movie. But the idea is that like one little thing can have ripple effects on so many other things across the world. But like your through your company, there's one effect. Stud.io could have a ripple effect on a project in China or somewhere else in the world because of this one little action. But okay, I'm deviating from our.
Well, I think so. Actually, one other thought that I have though about just the idea of kind of hard work versus luck is, and then there's a third thing that is maybe kind of a combination of this too, which is curiosity. And I, because for that year that I was working as a software developer at Autodesk, but still essentially prototyping some of the stuff for my business on the side, I didn't do that because there's going to be huge opportunity to start a company in the future for this. I just was really curious about that idea that a highly constrained machine has potential for high value use cases that no one has uncovered. And there's like these algorithms and stuff that you could develop to tap into that. I just thought that was fascinating and kind of couldn't help myself from exploring it. So maybe that's part of the recipe.
And what was the other one you thought of?
The other,
You said there was a third thing that you thought of.
I've made curiosity.
Okay, that was the third thing. Okay,
Or maybe if there was another thing, it's gone now.
it's gone now. So when you were developing this software, how involved were you in the coding of it? Because when I was getting into BIM, like becoming a BIM director, learning Python was a hurdle for me, and learning C# was a hurdle because it's a completely new language that is not just something you can pick up overnight. You have to basically be a computer programmer in addition to knowing architecture and construction and being a communicator. Did you outsource any of the coding, or did you learn how to code your proprietary software?
Oh yeah, none of it was outsourced, and until recently, it was 100% written by me. We
Oh
actually
my gosh, wow.
we do have another full-time software developer now, but and up until that point, it was entirely myself, and
That's impressive. What is it based on? What language is it based on?
it is C#.
Okay.
I think pretty much entirely. We have some web services that are JavaScript or TypeScript, but that you're right. Like, it's not something you learn overnight. Nor is, visual programming in Grasshopper or Dynamo. Nor is Revit, for that matter. So
that was entirely self-taught. You just went out and learned C# and JavaScript.
Yep. I don't know when I started learning C#, but so when I got my Master's of Architecture, I also got the Master's of
Computer science.
But like I said, it started, we were talking a minute ago about, I just kind of realized first semester of architecture school, I really liked coding this stuff. And I think I was coding in Visual Basic in Excel at the beginning, which is not great, but it became an obsession. And the first thing I learned was Grasshopper, and then I started this dual degree program with the engineering school in computer science. I get to start my own dual degree program, which was great. But that's where I really learned how to code well,
Okay.
was in the computer science department. But also just a lot of days and nights spent struggling through different problems. And I think that's really the only way to get good
Yeah,
at programming, is to have
absolutely.
something you're trying to do and not stop until you figure out how to do it.
Did you ever outsource any of did you get on Reddit and any other like websites online to seek help from other coders? I know you had people in your university, but did you go out by yourself and try to find experts in C sharp to learn
Definitely.
more?
Definitely.
Definitely.
Scouring Google
Yeah,
and therefore GitHub and Stack Overflow for this stuff all the time. And if you're writing C sharp for Grasshopper or Rhino, you should check out McNeil has a whole forum where people are posting what they're
that's true.
working on and stuff like that. I spent a whole bunch of time there, getting answers for how to do stuff and how to write code for my own plugin for Grasshopper and things like that. Um, but a lot of what I learned happened when I was at Autodesk too, like as an intern and as a software developer. And the person who jumps out, who's a great resource right now as well, is his name was Jose Luis. He teaches at the Harvard GSD currently, and he also has a YouTube channel for kind of teaching computational design. But there were times that he'd sit there while I was an intern and he'd whiteboard stuff with me, and he definitely sent me off in the right direction in terms of software development. Um, so that's also a great resource. This because he has a channel where
Okay.
you can.
I'm gonna have to look him up after this. Yeah.
Yeah, for sure.
So what is the software that you have built, what does it currently do? I went on your website and it says that your company offers project consulting, process consulting, and software licenses. But your primary focus of your business right now is this proprietary software that you've built. So what does the software do to the layperson who just knows a little bit
Yeah,
about
I mean,
construction?
at a high level, the software turns an architectural design into fabrication information for machines that make the parts to build that design. And it's specifically designed to handle complex geometry. It can do your typical walls that are meeting at 90 degrees, or it can do the simple stuff, but it was built to handle the complex stuff as well.
How does it differ from any other software out there that does analyze structures and break it down into modular parts?
I think maybe a couple ways. I think the first is what I said about, it's
Unlocks
meant,
potential that other software
yeah,
doesn't. Yeah.
it's meant to be highly customizable,
Yeah.
including in terms of geometry. Um, I think the second is that it's designed to be used parametrically as well. So I don't think there's another light gauge roll forming software out there that you can use in Grasshopper, for example. Um, but then the third, I think, and maybe the most important thing is the software's set up as a solver. The kind of core algorithm is a solver that solves fabrication constraints, which is a hard concept to maybe describe without a lot of visuals. But the idea is that when you have a bunch of parts, which is the stuff that we make is typically, it's not like one part that goes to site. It's 100 parts that come together like Legos to form a module that goes up onto the building. But those parts have to connect, and there are geometric constraints around how those can connect. And the software kind of figures all that out. So you give it the shape, and it gives you all your studs that are connecting in certain ways, and it gives you the fabrication file. You go just insert that into the machine to make all those exact parts.
Does it also give you like a list of materials for the connectors?
Yeah, well, so in the case of steel studs, it's just screws. But yes, it would give you the number of screws that you need. Um, and it automatically spits out the assembly drawings, which we found is kind of limiting. So we're trying to move towards assembly animations, actually, so people can
Ah,
see it and
it's a little more
3D.
exciting. Yeah.
Yeah, right.
Very cool. What are some big projects or like passion projects of yours that you've actually used the software on?
So the first and still one of the biggest was the Lucas Museum in Los Angeles. Still being built right now, but I mean, that was just a super exciting project to get to use the software on because it's freaking George Lucas and it's
Yeah.
this mad architect spaceship looking building. Um, so there's that, and then we have 2 projects in Las Vegas that on the Strip that I'm super excited about, and the first is the MSG Sphere, and our scope's pretty much complete there actually, and then the other is Fontaine Blue, which is just down the street and has this entryway that maybe it's because I just finished working on it, but I think it's the coolest project we've ever done. Just in terms of like the value that we brought to the project, and also the framing looks really cool. The actual product that we're delivering looks really cool.
When you mean the value you brought to your project, it's almost, do you feel like that couldn't have been achieved without your software? It was such a complex geometry that it would have been almost impossible to build it without StatIO software?
I don't think I can claim that
Yeah.
because, like, surely it can be figured out a number of ways.
But a lot more laborious method, maybe.
I would imagine way more laborious. But see, the problem, I wish I could tell you, like, and I think I have some metrics that I'll get to in a second, but it's hard to say when we come into a project, it's going to be
50%
75.
cheaper, yeah.
Yeah, because usually what we're doing is one-off projects, right?
Yeah.
So we could say that if we were building one and then someone was building one in a different way.
An
right,
identical building, yes.
Exactly. And I would love for that to happen because I would love to have a hard metric to be able to point to, because you do obviously get a feeling like, okay, we sped this thing out quite a bit. You can't really prove that. You can only go against, so you can't go against some identical project being built elsewhere, but you can go against what was budgeted. And typically we see that and we know that we're improving things. And we, like, on a couple of these projects, we've seen the time that was budgeted for assembling the parts or for installing the parts in the buildings cut into like a third.
Wow. That's impressive.
And it gets better and better every time. And those Vegas projects in particular, I have to say, is this Fontaine Blue one is, I hope, going to be one of our most efficient projects that we've done. And it's because we also did the MSG Sphere with that same team. So
you're getting to know each other, know how the other subs work. Yeah.
Exactly. And the big part of that is, building rapport and building like a common language and understanding with the people in the field who are actually going to be putting it together. So anyways, that collaboration with that team in Vegas, which is the KHS&S team in Las Vegas, is super exciting to me.
How much feedback do you get from these projects that helps you update your software, make certain tweaks that you wouldn't have thought of if you weren't actually working on projects?
A lot. I mean, that feedback is some of the most valuable stuff that we get.
So you being on site in California or in Colorado, do you make a conscious effort to go on site and talk to the people installing it to get their direct feedback, and then you incorporate that into the software?
Oh yeah, absolutely. Because we talked about how I got started in framing, and it was as an intern as a software developer, right? So I do now, but when I started, I didn't know really anything about traditional steel stud framing. So every project you go out there and you see the people putting it together, and they come from a completely different perspective, and something that you thought maybe was super intelligent or how you were designing this thing, they're like, no, they might think it's
That's
really dumb.
yeah.
And they might have a really smart alternative that they were, oh, okay. And then we just bring that back into, our workflows and potentially even our software.
What do you see the future of Stud.io being? Would you still continue building the software side of it, or do you see yourself becoming a fabricator at some point?
So our current focus is on software. Um, so probably the next year, what we're going to focus on is building up the software and making it more usable for more people. Because the only way to really use it right now, there are some other ways, but the best way to use it right now is inside of Grasshopper, which we usually run on top of Rhino or Revit. And Grasshopper is a visual programming language, and if you don't know how to do that, you're kind of kept from using our software and using the more powerful parts of our software. So the next year, we're going to focus on the
UI part of it?
Exactly. Improving the user interface in Revit would be specifically our focus. And we've started that, and it's promising. And people we've talked to about it are excited about it.
Because the eventual goal is for you to get this into the hands of other architects, other designers. Because that's the only way it will scale up. Y'all can't be designing every single project that comes across your table.
Yes, exactly. And that's already happening. And it's the most exciting thing to see people using the software. And because then you learn from that too, because people figure out their own ways to do things, and people see features that they would be really helpful to them that we never would have thought of for ourselves.
Maybe their own ways to break things too. Right?
Seriously. Yeah. Seriously, I would love for people to push the boundaries of the software and find where it fails so we can extend it in that direction.
Absolutely. So we talked about the business, and we talked about your passion for computational design. But the mind-boggling thing is, in addition to building this company and building the software side of it, you're also a part-time professor at your alma mater.
Yeah.
How on earth do you find the time to do that?
It's crazy, but all this stuff is a lot of fun, and we've gotten really good at executing projects, so I don't have to we can kind of trust that that's going well.
Yeah.
But it does feel like I have a lot of balls in the air, and you have to trust that other people are going to catch that and kind of do their part of things. So that trusting people, building relationships, and collaboration is a huge part of how I've found myself able to be involved in a bunch of stuff like that.
So what's the program that you're developing at the architecture school?
Yeah, so I'm co-teaching a class, so it's not necessarily like I've stepped in to reorganize their program or anything. But so WashU is where I went to school, and I'm co-teaching a class focused on intelligent prefabrication. So that's the name of the class. And there's obviously a lot that I've picked up over the past few years in terms of how to design prefabrication systems. And so that's what I'm trying to impart to the students, is the thought process around that, and thinking at the core level of geometry, thinking about the lines and the planes associated with these things, and how you build computational workflows and software on top of that. And the really exciting thing is that the students are actually using our software and are designing structures in them, and we're going to build a whole bunch of full-scale prototypes that they've designed at the end of the semester.
I love that. I think it's so valuable when professionals who are out in the field come back to architecture schools. And the reason I say it is because I feel in a lot of ways architecture education is disconnected from reality, because the professors are theorists. There isn't enough practical knowledge being disseminated at architecture schools. So when someone like you comes along that has experience on site that talks to um, builders and engineers every single day, you can give the realities of the architecture, of the world of architecture, the world of construction to these students. They are not like, for me, when I graduated, I had a very unrealistic view of the construction industry. And it was really disappointing. And when I got into the real world and I was designing chain restaurants, that was straight out of architecture school. That was a very deflating. So
Sure.
for you to come in and tell people, yeah, I think it's very valuable to students.
Yeah, and I hope that they see like these alternative.
Career
For one
paths,
thing, yeah,
yes.
but to what you're saying, also yes, that just like talking to people who are in the profession. If I wish I had done more of that as a student. Um, but also like that. Yeah, the big thing I'm coming in there and I kind of explicit with the students is, hey, you don't have to be an architect. Being an architect is great, but there's a whole bunch of other things you can do with the skill set you're developing
Yes.
in architecture school.
Because the skill set's very valuable. It takes a while to figure out how to use it properly. And
Yes.
if that gap could be shortened, if it could be eliminated, maybe it would be so helpful. You wouldn't have to go through these 10 years of grunt work to finally figure out your path in the construction industry.
Yeah. No, I think that makes a lot of sense. Um, I mean, you talked about that you did an externship. Like, I'm sure that kind of stuff is also super helpful while you're in school.
It was definitely. And it also, like, I did these co-ops in DC, in New York, and in San Francisco, and in Dallas. So getting exposure to different parts of the country and different cultures, and it also helps you figure out what you're comfortable with and where you want to live.
Yeah.
In addition to and the funny thing is that I worked at an interior design firm, at a construction firm, at an architecture firm. That exposure is really vital. You don't always have to just do an internship at an architecture firm. So
Yeah.
there are options. Yeah.
No, yeah, because I did a similar thing. Where so my first couple internships were at architecture firms, but then I went to an internship at a company called Zaner, which is a metal fabricator in Kansas City. And then I went to that internship in Autodesk. So like I was like you. I was like, I want to try like a whole bunch of different stuff, which I think so students need that. I hope that this class can be a little bit of that, so they could see that, because I work in construction. Studio does construction, but there's a lot of design, and we take pride in like I I take a lot of pride in what the studs look like that no one's ever gonna see. but I also I make sure that that the focus is on making them make sense in terms of how they go together and how they're communicated to the people building them. But that sort of design, that focus of design still produces something with this like aesthetic value. Um,
I think what you're saying is that design, there are different layers to design. It's not just about the outside facade, which sometimes architecture schools focus on. Like the design of the studs can be equally as important as the cladding on a building.
exactly,
Yeah.
exactly, and you're focused on something different, right? Obviously, the function of the studs and the framing is different from the function of the finish, but it has its own. There's a beauty to it, and you can find an aesthetic in it.
So when you teach these students, is there one piece of advice you try to share with them that, I don't know, you gained through your experience or through this career that you've carved for yourself, that for a student that's interested in carving an alternative path in computational design, what do you try to tell them?
Yeah, I've already said this to my students. I think it's very important to be curious and to be guided by that curiosity. And I've already mentioned that in this discussion. But that has taken me so many places, right? It's fuel, for one thing, to focus on something and push through hard moments, because you just have this curiosity to so I think if architecture students, and even if it's not computational design, if they have something that they're just super curious about, you should go for it, like, explore it, because there's a good chance that if it's valuable to you, it's valuable to the larger industry, or could be, after it's been explored for a certain amount of time. So, and I also think like curiosity is the way I built stepping stones to learn how to design computationally and to learn how to code, because I'd be curious about just one little thing. How do I
How do I
computationally
solve this
design?
one problem? How can Excel help me solve this
Exactly.
one problem?
Exactly. And so, no, that doesn't guide me for a decade, or a year, but that gives me something to focus on for a couple days, and you'll learn. Um, so, so my piece of advice is to be curious and to follow that curiosity.
Well, thank you so much for sharing all that information with us. It was really nice chatting with you. We need to team up on a dedicated video on Stud.io because y'all are doing some really cool stuff. I would love, we didn't really have any visuals in our discussion over here, but I would love to show the visuals of how your software works and how you'll convert this like generated design into reality. But we should definitely team up on some videos, some educational videos on that.
Oh yeah, we will do that.
Yeah.
Sounds
All
great.
right. Thank you so much once again, Scott. It was fun chatting with you. Hope to
Yeah.
chat again soon.
Likewise, thank you so much for having me.